Good day, everyone. Today I will be discussing network protocols and communications. Before we start, let us first define some terms that we will be using in this discussion. First term, network, consists of multiple devices that communicate with one another. It can be as small or two computers or as large as billions of devices. Second, protocol. A protocol is a standard set of rules that allow electronic devices to communicate with each other. These rules include what type of data may be transmitted, what commands are used to send and receive data, and how data transfers are confirmed. The third term is TCP/IP, or Transmission Control Protocol Internet Protocol. This protocol is a suite of communication protocols used to interconnect network devices on the internet. TCP/IP can also be used as a communication protocol in a private network, such as the intranet and an extranet. The fourth term is data link. A data link is a method for communicating one location to another in telecommunications in order to transmit and receive digital information. Data transfer happens over a certain link protocol that allows data to be transferred from the source to the destination. Next, we have web server. A web server is a computer system that hosts websites. It runs web server software such as Apache or Microsoft IS, which provides access to hosted web pages over the internet. Most web servers are connected to the internet via a high speed communication, offering OC-3 or faster data transmission rates. Next on the list is the Internet Protocol, or IP. The IP is a protocol or set of rules for routing and addressing packets of data so that they can travel across networks and arrive at the correct destination. Data traversing the internet is divided into smaller pieces called packets. IP information is attached to each packet, and this information helps routers to send packets to the right place. Next is Telnet. A Telnet is a two-way communication protocol which allows connecting to a remote machine and run applications in it. Next is FTP, or File Transfer Protocol. The file transfer protocol is a protocol that allows file transfer amongst computer users connected over a network. It is reliable, simple, and efficient. Next, we have SMTP, or Simple Mail Transport Protocol. This protocol is used to transport electronic mail between a source and destination directed via route. Lastly, we have DNS, or the domain name server. The domain name server resolves an IP address into a textual address for host connected over a network. So please keep in mind the following terms because this is very important for the succeeding discussion. Now, let us go to our next topic, which is rules of communication. This rule is all communication, or the first rule is all communication methods have three elements in common. We have the source or sender. Next, we have the channel or media. And lastly, we have the destination or receiver. Let's take this as an example. For the source or sender, a person writes a letter, inserts it in an envelope, writes the sender and receiver's address, drops the letter in a mailbox. The letter then is picked up by a letter carrier and delivered to the post office. The letter is sorted at the post office, then a carrier transports the letter. Next is the channel or media. The letter now is sorted at the post office, then a carrier transports the letter. Letter is brought to the recipient's local post office or may be brought to the central office. It may be transported by a truck, a train, an airplane, a boat, or a combination of this. Next, we have the destination or receiver. The carrier transports the letter to the post office. The letter is then sorted and delivered to the recipient's mailbox. The receiver picks up the letter and opens the envelope and reads it. The next rule is protocols govern all methods of communication. The next is establishing rules. Protocols are necessary for effective communication, and in order to achieve this, sender and receiver must be identified. Common language and grammar must be observed. Speed and timing of delivery must be observed also. And confirmation or acknowledgement requirements must be done to ensure that the data being passed over the network is correct and complete. And that's how you achieve an effective communication. Protocol used in network communications must be defined. Network communication protocol must be followed. The following must be performed on the data to ensure data transfer. We have to, we a message encoding, message delivery options, message formatting and encapsulation, message timing, and message size. Now, let us go to network protocols and communications. There are two rules that govern communications. The first protocol, suits are implemented by host and networking devices in software, hardware, or both. The second is The protocols are viewed in terms of layers to ensure that communication between two or more parties is established. Now, let's define protocol suites. Protocol suites is a set of protocols that work together to provide comprehensive network communication. An example of protocol suites is TCP/IP, and some of the protocols that we have defined earlier, like Telnet, FTP, SMTP, and DNS. Those are examples of protocol suites. Now, let us discuss TCP/IP communication process. When receiving the data link frames from the web server, the client process and removes each protocol header in the opposite order it was added. This will be discussed more on the following slides. We now go to open system interconnection, or what we call OSI reference model. The model uses layers to help give a visual description of what is going on with a particular networking system. This can help network managers narrow down problems like, is it a physical issue or something with the application? As well as for computer programmers, like when developing an application, which other layers does it needs to work in? There are seven layers in the OSI reference model. Let us now discuss them one by one. We start from the bottom. The first one is the physical layer. Now, the physical layer represents an electrical and physical representation of the system. This includes the cable type, radio frequency link, such as the 802.11 wireless systems, as well as the layout of pins, voltages, and other physical requirements. When a networking problem occurs, the physical layer is the first thing to be checked. Make sure that the cables are properly connected and that the power plug hasn't been pulled, like the router, switch, or computer. The second layer is the data link layer. The data link layer provides node to node. Okay, so when I say node to node, it means from one computer to another. Node to node data transfer between two directly connected nodes and handles error correction from the physical layer. Two sublayers exist here as well, like the media access control, or what you call the MAC address or MAC layer, and the logical link layer, or the LLC layer. In the networking world, most switches operate at layer 2. The third layer is the network layer. This is where most of the switching and routing functionality is found. It provides switching and routing technologies, creating logical path known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing, internetworking, error handling, congestion control, and packet switching or sequencing. Next is the transport layer, the fourth layer. Now, the transport layer deals with the coordination of the data transfer between end system and host. How much data is needed to be sent and at what rate, also where it goes, and many more. The fifth layer is the session layer. Now, this layer establishes, manages, and terminates connections between applications. The session layer sets up, coordinates, and terminates conversations, exchanges, and dialogues between the applications at each end. It deals with session and connection coordination. The sixth layer is the presentation layer. Now, this layer provides independence from differences in data representation, example, encryption, by translating from application to network format and also vice versa. The presentation layer works to form data into the form that the application layer can accept. Its function includes data file formatting, translation, encryption, and also compression. This layer formats and encrypts data to send or to be sent across a network by providing freedom from compatibility problems. It is sometimes called syntax layer. Lastly, we have the application layer. Now, this layer is the closest to the end user. The application that works at layer 7 are the ones that users interact interact directly. So those are the seven OSI reference model. Again, we have the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. Now, let me discuss to you the TCP/IP model. This is the counterpart of the OSI reference model. The TCP/IP model is a condensed version of the OSI reference model consisting of the following four layers. We have the application layer, the transport layer, the internet layer, and the network access. As you can see, in the application layer of the TCP/IP, three layers of the OSI can be done in only one layer of the TCP/IP: the application, the presentation, and the session. And then you have the transport, which also equivalent to the transport layer of the OSI, the internet, which the equivalent of network in the OSI model, and the network access, which includes the data link and the physical layer of the OSI. Now, let us discuss these layers one by one. The TCP/IP model layers. We'll start from the bottom. Okay, first we have the network access, or sometimes referred to as the network interface layer or the host to network layer. This is the lowest layer of all. Protocol is used to connect to the host so that the packets can be sent over it. And also, it varies from host to host, okay, and network to network. The next layer in the TCP/IP model is the internet, or the internet layer, or sometimes it is called the network layer. Now, the network layer selections of a packet switching network which is based on a connectionless inter-network layer is called an internet layer. It is the layer which holds the whole architecture together. So this is very important layer. It helps the packet to travel independently to the destination. An order in which packets are received is different from the way they are sent. The IP or the Internet Protocol is used in this layer. So there are various functions performed by the Internet layer, and they are: number one, delivering IP packets. Second, we have the performing routing. And the third, we have the avoiding congestion. So those are the different activities involved in the internet layer. The third layer in the TCP/IP is the transport layer. Now, the transport layer decides if data transmission should be on parallel path or single path. Okay? Functions such as multiplexing, segmenting, or splitting on the data is done by the transport layer. The application can read and write to the transport layer, and also the transport layer adds header information to the data, which is important in data transmission. Transport layer breaks the message or data into small units so that they are handled more efficiently by the network layer. The transport layer also arrange the packets to be sent in sequence. Lastly, we have the application layer. Okay, the TCP/IP specifications describe a lot of applications that were at the top of the protocol stack. Some of them are what we have defined earlier, which is the telnet, the FTP, the SMTP, the what else? The DNS, okay, and many more. There are a lot of protocols, okay, for the application layer. Now, let us discuss the similarities, okay, and differences of the OSI model and the internet model, or the TCP/IP model. Okay, so the OSI model and the TCP/IP reference model have similarities, four similarities to be exact. Okay. First, we have both have layered architecture, as you can see. In the OSI, there are 7 layers, and in the TCP/IP, we have 4 layers. Next, we have layers provide similar functions. So, like what has been shown in the illustration before. Okay, some of the layers, multiple layers in the OSI is also performed, okay, in a single layer, okay, of the TCP/IP model. Number three, both are protocol stack, so they uses different protocols like what we have mentioned. We have the telnet, the FTP, the SMTP, and the DNS. And lastly, both are reference model. Okay, so when you say reference models, okay, they make use of different or multiple protocols, okay, for each layer. And that ends this topic. I hope you learned something, and thank you for listening.